All right, grade 5, we are continuing with our big idea of describing patterns in tables and graphs can help us to solve problems and describe the world. Today, we are working on demonstrating and understanding that an expression can be used to express a pattern rule. So it's another way of expressing a pattern. So we've talked about tables, we've talked about rules. Now we're going to add expressions as a way to communicate the rule, or the pattern, communicate the pattern. In fact, if we look at the picture below, sometimes patterns can also be shown in a picture format, depending on the pattern itself. Here we have a pattern of line segments drawn on dot paper. So figure number 1 has 2 dots, figure number 2 has 3 dots, figure number 4 has 4 dots, figure number 3 has 4 dots, figure number 4 has 5 dots, and figure number 6 has I keep mixing that up. Figure number 5 has 6 dots. There we go. Now, if you are ever to create a picture of a pattern, which you will have to in grade 6, one of the things to remember is that your picture needs to increase in a predictable pattern, in a predictable way. So here we can see that each time we're adding one more dot to the bottom, and it's very predictable. If we were to draw the next one, we would know that it would have to be 7 dots with 1 extra dot on the bottom. It's predictable. It's very clear as to what needs to happen again the next time. All right, so here we have the table, which shows the figure number and the number of dots. So we have figure number 1, 2 dots, figure number 2, 3 dots, and so on. And what we're doing each time is we're adding one more to the figure number. So figure number being 4, we add one more, which gives us 5. Figure number being 5, we add one more, which gives us the 6. So the number of dots is one more than the figure number is our rule. We can write each number of dots as this sum, figure number plus 1, and you can see that here, the figure number plus 1. The way that that could be shown is figure number plus 1, just like that. We don't need to write necessarily the whole thing there. Now, the key for today is being able to take that and write it into what we call an expression. Now, an expression always uses a variable. What is a variable? When we can use a letter, such as F, to represent figure number. F is called the variable. So instead of writing everything, because you know mathematicians sometimes like to take shortcuts and use symbols instead, the number of dots would be the figure, so figure plus 1 would be our rule as an expression. This is the expression, figure number, or F plus 1 is our expression. We have the variable being the letter that represents the figure. Couple of things to remember when you are choosing your letter that is going to be the number, take place of the number. Don't choose something that looks like a math symbol. Often they'll choose X, I don't know why, but when they choose X, they often write it like this, so it doesn't look like the times symbol. You don't want it to look like the times symbol. So that one's a poor choice. T is also not a great choice. If it's written a certain way, it can look like a plus sign. S is not great. If it's written a certain way, it can look like a 5. O is not great. It can look like a 0. Lowercase l is not great. It can look like a 1. So be careful when you're choosing what's going to represent your variable, what it's going to be. Okay, so this is the expression. Expression has a variable and it has a letter representing the words basically, or the unknown. So F plus 1 is the expression that they have there. When we want to check our expression, we can check that it's correct by completing the picture or continuing the pattern. So we've said that it's going to be plus 1. It should have 7 dots. And if you look at the pattern on the picture and being able to see what's happening, it would be plus 1 there as well. And that would give us our 7 dots. So as we said, we can use that variable to show our pattern. So let's take a look here. You can use a variable to write a pattern. Look at this pattern. So we've got 7, 8, 9, 10, 11 is our repeating pattern, or is our pattern here, increasing pattern, not repeating, increasing pattern. And we can see that here we've got each one being one more than the one before. So they've made this into a t-table. Quite interesting the way they've done that. This one being the term position. So the first number is 7. The second number is 8. The third number is 9. So that's how they've made this into a table. And what they've noticed is that the term number plus 6 gives us our new number. 2 plus 6, which was our term number, gives us 8. 3 plus 6 does give us 9, and 4 plus 6 does give us 10, and 5 plus 6 does give us 11. So the plus 6 being the rule part. Now, to express that as an expression, we need to replace, so it's plus 6, but we need to replace the front with a letter. And they've chosen to use N. N is a very common one. In this case, it's a good one because it can represent the word number. So that would be our expression. We can check it if we want and see that if we extend the pattern, yes, that is in fact what happens. The fifth term would have to be 11. All right, and now we get to practice. So with your partner, copy and complete the table. Yes, on your paper. Remember, when you do your practice with the videos, it's always on paper, not in your head. More effective on paper, generally more recalled and remembered if you do it on paper. Plus, if there's any errors, it's easy to determine where you might have made your mistake. So, copy and complete the table. We've got figure number and number of squares as our headings, so that's very clear. And then just fill in your table, figure out what the rule is, and then write it as an expression. And remember here it's saying write an expression to represent the pattern in number of squares. So number of squares is what we're looking for. Use your partners to assist you if you need to. And go ahead and try that right now. All right, so copying and completing the t-table. Figure number and number of squares are our headings. I've just put them into symbols more so just for ease of writing. Figure number 1, we go all the way up to 5, so 2, 3, 4, and 5. Figure number 1 had 1, 2, 3, 4, 5, 6 squares. Figure number 2 has one more than that, so 7. Figure number 3 has another one more than that, which is 8. One more again, which is 9, and one more again, which is 10. And you can see exactly it's a predictable increase here. We've got one more on the top, and then we add one more to that row, add one more to that row, rows of 3, and we know after the row of 3 we have to start back at the top again. So it's a predictable way in which that this picture is increasing. Now we need to write an expression and see what's happening here. And we're going across, so it's 1 plus 6, 2, or I guess 1 plus 5 would give us 6. Does plus 5 work? 2 plus 5 would give us 7. 3 plus 5 would give us 8. So yes, plus 5 is our rule. To make it an expression, we have to put a letter in front. Because it's figure number, I'm going to go with F. Figure number plus 5 would be my expression. Now with an expression, you do not want the equals part. Okay, so expressions don't have that. They just have the operations and the numbers and the variable or the letter. Remember, variable is another word for the letter that replaces it. All right, now you are onto your concept practice. Math Makes Sense, page 15, numbers 1, 3, 4, and 6. Remember to show all your work. Remember to write it as an expression, and when you choose your expression, seek to be understood and make it something that does not look like a symbol in math. Remember as well, if you have questions along the way, to please remember to ask. Away you go.